So now we come to what's called the power rule for derivatives. So let's just look at a couple of examples when we use this definition of the derivative, right? This is using the definition of the derivative, which is that limit as h goes to 0, f of x plus h minus f of x all over h. So if this was the function that we were using, this x squared plus x, and I plugged it in and I did a bunch of work, this would be the answer, okay? So starting with this, we get this for the derivative function. We did a few of those before. Okay, let's look at to see what happens when I use this function. Now, note that I would never have you multiply a cube thing out. So this is f of x plus h minus f of x. A bunch of work later, we get this. Okay, so here's the function and here's the derivative. So let's look to see if there's some kind of pattern. X squared, this turns into 2x. Oh, x cubed, that turns into 3x squared. So what the power rule says is if you have x to a power, and that's your function, to take the derivative, you bring that number down in the front, and you subtract 1 from the exponent. Okay, let's check it out. So if I take this x, this is like saying x to the 1 power. So if I do that derivative thing, I bring the 1 down, subtract 1 from the exponent. Oh, that's just 1, and that's what that is. Okay, so let's just go practice some more. So there's a special case. If you've got a number, the derivative of that number is 0. So the number could be the number 5 or pi cubed or e or square root of e. Derivative of any number is 0. So let's talk about this notation. This thing here, this d over dx, says take the derivative with respect to x. That means you're supposed to do the power rule on the variable x. If it says d over dt, then you're supposed to do the power rule on the variable t. Let's do these. So this says take the derivative of x to the 13. So I'm not going to write that d over dx anymore. So the derivative is 13 x to the 12th. There you go. Okay, we have to be careful. So this rule says, let me erase here so we can look at the rule all by itself again. This rule says it has to be written exactly like this. The function has to be written as x to a power. Then I can do the subtraction. Okay, this is not x to a power. So I need to say I'm going to take the derivative and then rewrite it as x to the negative 3. Now I can take the derivative. So I bring the negative 3 down, and then I subtract 1 from the exponent, so that's negative 4. So that's the answer. I'm always going to encourage you to take the time to rewrite it as the exponent that it is, because that's what you have to bring down, right? So you know root t is the same as t to the 1/2. So to take that derivative, you get 1/2, subtract 1, and I get negative 1/2. So just note, we never put negative 0.5. Just mathematicians, we don't do that. So just always use the fractions. All right, how about this one? Pi squared. You might think, bring the 2 down and then times pi, but that's not correct. Pi squared is a number, and so the derivative of this is 0. Taking the time to rewrite this, so I'm going to keep writing. I'm going to take the derivative of, and then rewriting this, it's negative and it's 1/3. So then I bring that negative 1/3 down, and then I subtract 1 from negative 1/3, and I get negative 4/3. Okay, and this one again, I'm going to rewrite. I'm just going to put the z to the negative 1 power. So now when I take the derivative, I get negative z to the negative 2 power. Okay, so that's the beginning of power rule. So let's look at some more rules in the next video.